but he sought by synthesis, that is, by combining the separate elements and forming substances similar to those constructed by nature, to prove the accuracy of his processes and the correctness of his conclusions. Thus he formed, for instance, pumice stone, feldspar, mica, iron pyrites, etc., artificially. But of all the achievements of inorganic chemistry, the artificial formation of lapis lazuli was the most brilliant and the most conclusive. This mineral, as presented to us by nature, is calculated powerfully to arrest our attention by its beautiful azure blue color, its remaining unchanged by exposure to air or to fire, and furnishing us with a most valuable pigment, ultramarine, more precious than gold. The analysis of lapis lazuli represented it to be composed of silica, alumina, and soda, three colorless bodies, with sulfur and a trace of iron. Nothing could be discovered in it of the nature of a pigment, nothing to which its blue color could be referred, the cause of which was searched for in vain. It might therefore have been supposed that the analyst was here altogether at fault, and that at any rate its artificial production must be impossible. Nevertheless, this has been accomplished, and simply by combining in the proper proportions, as determined by analysis, silica, alumina, soda, iron, and sulfur. Thousands of pounds weight are now manufactured from these ingredients, and this artificial ultramarine is as beautiful as the natural, while for the price of a single ounce of the latter we may obtain many pounds of the former. With the production of artificial lapis lazuli, the formation of mineral bodies by synthesis ceased to be a scientific problem to the chemist. He has no longer sufficient interest in it to pursue the subject. He may now be satisfied that analysis will reveal to him the true constitution of minerals. But to the mineralogist and the geologist it is still in a great measure an unexplored field, offering inquiries of the highest interest and importance to their pursuits. After becoming acquainted with the constituent elements of all the substances within our reach, and the mutual relations of these elements, the remarkable transmutation to which the bodies are subject under the influence of vital powers of plants and animals became the principal object of chemical investigations, and the highest point of interest. A new science, inexhaustible as life itself, is here presented us, standing upon the sound and solid foundation of a well-established inorganic chemistry. Thus the progress of science is, like the development of nature's works, gradual and expansive. After the buds and branches spring forth, the leaves and blossoms; after the blossoms, the fruit. Chemistry, in its application to animals and vegetables, endeavors jointly with physiology to enlighten us respecting the mysterious processes and sources of organic life. End of section 1. Recording by M.L. Cohen, Cleveland, Ohio, March 2007.